plus why is my mic muted? It should be working now. No, I think it could be my side. Okay, good. So I think, yeah, there was a setting within Restream that does noise suppression and those things, and I turned some of that off. So hopefully that fixes the issue. I apologize for that. So let's start over again. So basically, again, today's session is really on building a mobile, right, or portable OpenClaw platform. Right now, again, this is an unsupported solution, right? So, and the reason why I say is because I will be using Nutanix software. Full stop. I am a Nutanix employee, right? And so what I mean by that is I have access to the specific software that I'll be leveraging, and you will not have access to that, right? Unless you're a customer. But then again, what I'm doing is unsupported, right? Because Nutanix is really an enterprise grade platform. And what I'm doing is I'm fitting that into a small form factor solution that is portable. And I'm really going to cover what that solution looks like in the software components. And then in part 2, we'll get into the actual installation. And the reason why is because I was waiting on one thing, and that one thing just came last night, right? And it was an SSD. And so now I have the storage to actually build the platform. But we'll talk about the platform in a second. So again, this is really about agents, right? And really about exposing what OpenClaw, the power of OpenClaw and the autonomy that brings, or semi-autonomy, right? And one thing I talked about in previous sessions was, or in my previous LinkedIn post was, the 3 or 4 things that really OpenClaw exposed to the world, right? The first thing is it got us out of the chat bots, right? It exposed real agent utilization, how it could be leveraged. The second thing it exposed is the risk, right? And the dangers of using OpenClaw without control, governance, right? All of those things, security, etc. And that's the reason why I'm going to be moving towards NemoClaw on the platform, is because NVIDIA is solving for those things. And then the third thing I was talking about is it really opened the doors to the imagination, right? Because customers are now like, well, I could use agents for this. And now when you see it in action, it's like, wow, I can really use agents for X, right? And so, sometimes it takes a jolt, right? Or a few examples of how other people are leveraging tools and agents and things to kind of get your mind going on where you think this could fit in your environment, right? And so let's get into what I'm going to build. And again, I apologize for the first 5 minutes there on the mic here, but let's talk about that. So let me just go to share my desktop here. Okay, so I'm going to go to website. servethehome.com, which is a pretty good website when it comes to everything enterprise solutions, as well as home labbing and things like that. I've been a follower of them for forever, it seems. I think probably since it started. The forums are a great resource to buy used equipment, right, for home labbing, or to get information on, projects that you're working on. So again, this is the platform that I'm going to be building on. It's called the Minisforum MS02 Ultra. It's extremely small, right? Now, is it as small as a DGX Spark? No, it's not quite that small, but it's close. All right. And you're probably thinking, well, Mike, you have a DGX Spark. Why don't you just use that for this? Well, the reason is because I want a full platform capability, right? DGX Spark is ARM based, number one, right? It uses GB10. So it's using an ARM CPU and a Blackwell GPU, right? And some of the software I'll be using is not ARM supported yet. Okay, and this is the reason why I'm moving not moving, but I'm using this platform to build this portable solution. So what does the Minis Forum MS02 Ultra contain? So I'm just going to go up here and we're going to walk through. And so basically it comes with, the motherboard, right? An Intel Core Ultra 9 285HX, which is basically a mobile CPU of the current gen of Intel. That means it doesn't have hyperthreading, right? So it uses a 285HX mobile CPU running at 5.5 gigahertz, very, very fast and very efficient. And it has 24 cores. And it's a mix of performance, cores and E-cores. This is the big little design that Intel introduced in the core series, right? I won't be using Windows 11. This is what they tested with at Serve the Home. As far as memory support, this platform supports up to 256 gigabytes of DDR5 RAM, right? SODIMM RAM, okay? Now, you're probably thinking, oh, that's a lot of money. It is. Now, the good news is I already had most of that in another solution, which I sold without the memory to fund this. Again, it goes back to, how I do things is I don't buy like net new all the time. I can't afford that. I have to actually sell what I was using before to fund, right? Or to fund the next project. And what I do is I take a hit, no doubt about it, right? Obviously I take a hit, but how I look at it is if I can pay for 70+% of the next project, then I will sell and move on to next. That's how I view things. And so generally speaking, I take about a 30% hit. But what I say from that 30% is I'm learning, right? I'm using it to learn and I'm using it to share my experiences with the community, right? And so I'm not getting paid, right? I don't get YouTube money. As you can see, my YouTube channel is very small, right? I'm not a big YouTuber. I'm not doing content every week. And so I don't get paid from ads or anything like that. So I take personally the 30% hit, but again, I look at it as sharing with the community as well as, me learning things as well. So I don't have 256 gigabytes of RAM. I have 192 gigabytes. I'm using a dual 48 gigs, 448 gig SODIMMs, and that's what it has. It has 4 slots. So in an SFF, a form factor, that's generally unheard of. Now, I'm not saying that there's not other platforms out there. I know some of the Lenovo SFF platforms have 4 DIMM slots as well, but this is a newer platform with the latest CPUs. It supports 4 M.2 slots. Now, this gets a little tricky, right? So there's 2 M.2 slots, they're Gen 4 on the motherboard, okay? And then it comes with an add-in card that has a special slot on the motherboard that Minis Forum. And the add-in card is dual 25 gig NIC. It's an Intel. I can't remember exactly what it is. I think it's the 810 or 8 something series 25 gig NIC. And on that add-in card, that NIC, there's also a dual M.2 slots that you can place M.2. Now, because of the amount of PCIe lanes in this platform, right? It's not like, Intel Xeon or EPYC, right? From AMD, from a PCI lane perspective. You're not getting like, 100 PCI lanes on this platform. You're getting desktop, right? Type lanes. And so what happens is on the add-in card, the M.2 slots, they will go to PCI Gen 3, right? Lanes for those M.2 slots. So I'll be using that as, one of those slots as a boot device, right? For Acropolis Hypervisor when I run Community Edition. We'll talk about the software stack in a minute. And then the other 2 on board will be the storage for AOS, the HCI storage. Okay, so I'll have a 2 terabyte NVMe Gen 4, right, as the primary, as the first first AOS drive, and a 4 terabyte Gen 4 NVMe for the core storage. Okay, and so that's kind of how the storage will be laid out within the platform. It has an internal 350 watt power supply, and of course, it supports Intel graphics, right, on chip, right, on the Core Ultra 285HX. The form factor is SFF, right? It's only 4.8 liters, so it's very small. And it's generally speaking 8.74 inches by 8.86 inches by 3.82 inches. It's very small. So if you can see me, right, it's about like that big, right? So you can put it in your hand like this. Very, very small, very easy to work with. When you look at the back, there are two thumb screws you loosen up and it slides out of the chassis. So think of it's almost like a case, and then it's like a sled that comes out, and then you get access to all the components. It does have Wi-Fi 7. That's not important in this use case, and Bluetooth 5.4. I won't be using that. It has onboard two NICs, dual NICs on board. So in addition to the 25 gig ports that you get on the add-in card, you get a 10 gig Ethernet port and one 2.5 gig Ethernet port. You also get two USB-C ports at 80 gigabytes. So it does support Thunderbolt 4. Okay. Now, again, if you're using other software, like if you're using Proxmox or all those other things, you can do a lot of those things with those Thunderbolt ports, right? So you can, essentially, if you bought 3 of these, you could create a Proxmox cluster and use Ceph, and you can use the Thunderbolt ports, right, as the storage backend if you wanted to, and daisy chain the Thunderbolt. So there's ways of doing that. But in my use case, I will not be doing that, right? I'll be using one of the 25 gig ports that has a 10 gig SFP to RJ to Ethernet adapter, and that connects into my lab switch. Again, this is supposed to be portable, and so the idea is to leverage the enterprise grade or the Intel 25 gig, even though it's 10 gig. I'm down. The speed has been dropped down to 10 gig because of my SFP to Ethernet. The idea is to leverage that. Okay. If you want to see a video, here's the video. And by the way, you guys can look at this. If you want to look at this, right? You want to look at this now, you can go to Serve the Home and you can go to this link and you can actually play this video, or you can go on YouTube, Serve the Home channel, and you can find this and you can play the video. And Patrick goes through a full review of what this looks like. Now you'll notice that there is the 25 gig add-in card to the left. Let me go here to the bottom or to the top here, to the left here. And you also notice that there's two slots to the right. Okay. And that will accommodate a low profile dual slot, up to a dual slot, low profile GPU. And so what GPUs fit in there? Well, there's a few GPUs that fit. Now you can go the cheaper route and go with, say, an RTX 5060, right? I don't recall if they make 16 gig version. So I know Gigabyte and Asus make a low profile, small form factor GPU that will fit in here. And it is supported because it does come with the 8-pin adapter for those GPUs. But you can also put in, if you have the money or you have the funds or you have these devices on hand, you can also use an NVIDIA L4, right? Now that's a single slot. The challenge with an L4 in this chassis, that will be cooling it though. So you're going to have to do some custom cooling in there to make sure that L4 is sufficiently cooled. Because on the right-hand side of this chassis here, there are vents, but there are no fans that come in right through here. Okay, there's this intake fan here, which goes across the backside and the RAM. Okay, and the NVMe, as well as cooling the CPU. And then there's the GPU over to the right, which you'll place in there. And then within that GPU, right, you're going to have active cooling on that GPU. So the L4 does not have active cooling. The idea of the L4 is because it's enterprise and it's an entry-level enterprise or edge solution or workstation, that it's in a chassis that airflow passes across it, right? So you're using chassis that already have fans that pass across the PCI bus or the PCI ports, and therefore you're getting that cooling automatically through the chassis. Within this environment, an L4 will be hard, especially when you start using it, right? And you start hitting it for inference and those things. So you're going to have to figure out a way to cool it. Now, in my case, I'm going to be using something I've had for a couple of years. I've had this GPU for a couple of years, and I didn't want to sell it. It's an RTX 4000 SFF Ada. Okay, so it's a previous generation from the Blackwell, and the Blackwell just got released a few months ago. There is now an RTX 4000 SFF Blackwell, and it looks exactly the same. Okay, now what I've done is I've modded mine, and actually taken out the aluminum heatsink that comes with that. Now there's a fan too, so it's a blower type card, very small, low profile. And I took out the aluminum heatsink and I replaced it with a full copper heatsink and liquid metal. Okay, so that dropped the temps by about 4 or 5 degrees on average. Not bad, not a bad gain for doing that. But yeah, it definitely worked out in my favor, but it still gets warm. Okay, it's not like but it's a 70-watt card too, by the way. Okay, that's another thing I want to point out. Remember, you only have 350 watts to play with in this chassis from a power budget perspective. And again, I don't know if this is a gold rated power supply. It doesn't say here. And so you have to be very careful around the power budget here. When you put a GPU in here, the Intel iGPU automatically gets disabled. So you have to go back into the BIOS and re-enable it if you want to leverage the iGPU. What also happens is that your wattage for your CPU drops. Okay, so without a dedicated or discrete GPU in this platform, you'll be able to leverage. I can't remember the full wattage of the GPU. You'll be able to go the full wattage of the GPU, but when you place the GPU, a discrete GPU in here, it will lower the wattage, I think, to 90 watts for the GPU. Okay, so I think it's like 100 something watts for the GPU or CPU, excuse me, without a GPU, and with a GPU, it drops to 90 watts. Okay, so just be cognizant of that. Again, you're not going to see much of a difference in what you're probably going to be using this for unless you're gaming, right? So if you're gaming or doing something that's heavy GPU or GPU heavy, like you're doing some sort of something that requires CPU that doesn't have an offload to it, then you'll see obviously that will impact that. So things like compiling, right? Doing some compiling or doing 7-zip compression or something like that. You'll see some degradation there because you have a discrete GPU. Okay. Now you can see the back here, the 10 gig ports, the 2.5 gig ports, etc. Right. I'll be using I won't be using any of these. Now, one thing you can do is that the 2.5 gig supports Intel vPro. So you can use Intel vPro as a remote IPMI solution, right? To actually remote in, mount ISOs, install, etc. I'm not doing that. I have a Jet KVM. I have actually a couple of those, and the Jet KVM plugs right into this. Hindsight, I probably may go back to using Intel vPro because Jet KVM has fundamentally some not flaws, but it's not fully capable like an IPMI, right? So to copy and paste, you can copy and paste, but it's like typing. So for example, I'll actually show you right now. Let's go to the Jet KVM. Is it 2 or 5? Let's go to 5 really quick. Okay. So in order for me to copy and paste here in the Jet KVM, I have to use this. And when I paste, it actually types it out, right? I want a real web-based IPMI solution where I just copy and paste within the web and it just does it, right? So that's kind of a pain. The Jet KVM also relies on the power of the system itself, right? So meaning that, in Intel vPro, if it's plugged in, that Intel vPro chip is going to be running just like an IPMI or a BMC, right? And you'll be able to connect to it without the system being on. The system actually has to be on in order for the Jet KVM to work. So it's kind of like a, chicken egg thing, right? Okay, back to this. Let me just check and see if I have any questions here. Or if there's anything else. Okay. All right. So that's pretty much the platform. Again, I won't be using Wi-Fi. It's fairly small, and pretty much I'll have 192 gigs of memory, not the full 256 that it supports, because it was cheaper to buy. It's funny, when I moved to Florida, I'm close to a Micro Center. Micro Center had a massive sale on 96 gig kit of SODIMM memory, which matched what I already had. And so I bought that because of that sale, instead of me going to buy, the memory to make 256. that would be rebuying everything, and it would be atrocious. And, memory prices are very high. I know they're dropping drastically right now, but when I was looking at this, they were extremely high. And so I had to be very, very careful about the budget on this. So it's basically fully loaded, right? The RTX 4000 SFF Ada will be the inference engine, so to speak, right? The GPU, right? The accelerated compute that's going to manage my models partially. And this is what's the beauty of this platform is going to be. So let me get into, and there's a lot of pictures you guys can go. Again, I'm not going to go through everything here, but this is what it looks like, right? I have it stood up right on the feet here. That way my GPU and everything is able to breathe, because all these panels have perforation inside, and then the airflow goes right through the platform. Okay, so let's move on to the software stack. No. And the software stack is basically right here. Okay, so I'm just going to go through this really quick, and hopefully you guys can see this. I'll just make it bigger here. But essentially, right, it's basically the Nutanix full stack platform with NVIDIA software. Okay, so essentially what I have, again, the accelerated compute, et cetera, is all part of the MS02, right, the RTX 4000 SFF Ada. And then you have to the right-hand side, the data infra, right? So before I get into the data infra, and I don't really care for this slide, to be honest with you, how it's laid out, but let's get up to the next purple box here, to the infrastructure side of this. So the infrastructure, and this is up in the air, by the way, because this hasn't been tested yet, okay? And what I mean by that is the RTX 4000 SFF Ada is generally not an enterprise GPU. It's a workstation GPU, and therefore Nutanix hasn't validated that GPU with Acropolis hypervisor. And so, but we do support pass-through. And so what I'm going to do is I'm going to validate to see if I can just pass through this GPU to the actual node, the Kubernetes worker node VM, and see if I can actually run this, right, and get GPU working that way. If that doesn't work, right, the backup plan is to just run bare metal NKP, which is our Kubernetes platform, on the MS02 Ultra. Okay, that would be the plan. It would be kind of a single node solution. Again, not optimal, not really what you really do, but essentially what it would be is a control plane that allows for workloads to be run on it, right? So it's basically tainted to allow the workloads, right, on the control plane. And I'm not sure if that's going to work either. So this will be, I'll be testing this, right, as I implement the software and to see what works. The hope is to layer in all the Nutanix software to make it easy, right? Because it's integrated. It gives me everything I need. It gives me the compute, right? It gives me Acropolis hypervisor, which allows me to build nodes for my Kubernetes nodes. It allows me to build other workloads, right? It allows me to run NUS, which is the data services component, right? Which will be actually the storage for my models and for my persistent storage for all my other applications, right? Persistent storage for possible KV cache offload, right? Those types of things. And so that's kind of the idea, is to run Acropolis hypervisor with AOS, which is our storage stack, right? And then on top of that, the data infra will be handled by Nutanix Unified Storage, which is basically, in my case, will be leveraging NFS, okay? And then within that, we'll be layering on top of that Nutanix Kubernetes platform, which gives me the Kubernetes layer. And because I'm using Nutanix solutions, Nutanix Kubernetes platform already integrates into Prism, which is our control plane, as well as the CSI, right, for storage, for block storage, and for file storage for NFS. Okay, so that's already integrated. So it makes it very, very easy. And I can deploy, if I wanted to, the next stack, which is the Nutanix Enterprise AI component, right, the control plane for, and platform for AI services, right on top of the NKP platform. So now I have this full stack capability that gives me everything I need: the data services, the compute control, right, the Kubernetes layer for orchestration, and then the model management and model delivery through Nutanix Enterprise AI. Now, some of you are probably asking, Mike, why would you do all of that when I can just, and by the way, I have a Spark too. Why don't you just use a Spark and just use NVIDIA software to do this? The reason why is because it's all manual. Okay. I'm just going to tell you like it is. Okay. The NVIDIA Spark, you can do several different things. It's a very powerful solution, right? I love it, right? I still use it today. Matter of fact, I'm running NAI with DGX Spark right now, which is unsupported. I had a previous podcast on that. It's not going to allow me to run everything I need it to run because it's ARM based. Okay, so that's part of the problem. The other part of the problem is it's very manual. So for example, when I want to deploy a model, I have to manually deploy a model. Now people will say, well, you can use Ollama and all that. What I'm talking about is enterprise grade model operations, not, oh, here's a model and just connect to it through Ollama. That's easy. Anybody can do that, right? What I want is a platform, and let me show you, right, that gives me metrics, that gives me the ability to use unified gateway to route outside of my platform, right? So for example, if I want to leverage the power of Anthropic or OpenAI or Bedrock, I have the ability to do that because I have a unified gateway as part of the NAI platform. So now, and you can see here, you're looking at a unified endpoint that gives me access to a locally serviced Quen model and also GPT-4o Mini at OpenAI, right? So this gives me the decision of, can I use a model that's local when I'm disconnected, or when I'm connected, give me access to super intelligence, right? And I know it's kind of a marketing term, but think about it, right? I can now have access to super intelligence when I need it and localize intelligence when I don't, or when I'm in a disconnected state. Okay. And so that's the idea. Now you can do some of that using open. I'm not saying you can't do that on DGX Spark. So if you want to use Open Router, you could do that, but you get to pay for that, right? You have to pay to use Open Router and then pay for the access to OpenAI. So the idea is to kind of keep the costs low, make it portable, right? I won't have the same power, as you know, as the DGX Spark because I'm using an RTX 4000 SFF Ada, and it only has 20 gigabytes of VRAM as opposed to the 128 gigabytes of unified memory on the DGX Spark. And so there's pros and cons. This is an architectural decision that you're making, right? You're thinking about, okay, what am I going to use this for? What am I going to get the best bang for buck, right? Where am I going to be able to still get portability like the DGX Spark? And where am I going to get enterprise grade operations around metrics, models, automatic orchestration of model delivery, endpoint delivery, right? MCP controls, unified gateway to route outside of the platform and to use super intelligence at the frontier model providers, right? And so this is what I'm talking about. That's not easily doable on DGX Spark. I don't care what anybody says, because you can go in there and say, well, I have these scripts. I made these scripts, or I installed Grafana. That's already done for me when I install the Nutanix platform. That's the difference. Okay. And so I'm getting to basically to utilization. I call it ready to consumption much faster than I am with DGX Spark. Okay. Now there's other things that I can do too to make this DGX Spark like, for example, right? When I look at let's look at a local endpoint, right? I'm using the GB10, right? This is shared, right? So I'm just going to make this bigger so you guys can see it. This GB10, right, is you see it shared. That's generally not available in Kubernetes, right, on the DGX Spark. So I'm able to now implement GPU time slicing. Now, I know this is not optimal, but now I can slice up GPU time, right, on any GPU using GPU time slicing using Kubernetes, right? Now, within the DGX Spark, when I do Docker, right, and I deploy VLM and it's Docker container, I'm using NIM or whatever, I can use the GPU's memory as much as I want, as long as I don't go beyond that. Okay, so you get that kind of time slicing capability almost, right, natively by just using Docker and all that. But again, those are all manual things. I don't want to do this manually. I want to have an enterprise grade platform to make it usable, right, in a real experience, right? DGX Spark is more like a development box. I'm talking using this as like, what if I need to take my agents with me, right, to a job or to some place where I need the power of all these agents, right, that I build in OpenClaw, right, or NemoClaw. And so this is what the goal of this is. And as a matter of fact, the other goal is to actually have enough claws, right, to actually manage this entire environment for me as well. So think about this. chicken before the egg, I get it. This has to be up and running before the NemoClaw agent or the OpenClaw agent can actually manage this environment. But the goal is to have it be, give it autonomy or semi-autonomy within all of the solutions, right, of this platform itself to self-manage as well, to give me notifications if there's a problem with the platform, to give me, to say to me, hey, Mike, this is not set up correctly or not optimally set up. You should do it this way. You're going to get better outcome from this or better value. That's what I wanted to show with this, is not only just for external services, right? Meaning bringing agents to an external engagement, right? But also self-managing the platform itself. Okay. And so going back here, right? Going back to the thing here, it's essentially, leveraging the Nutanix platform and then layering in NVIDIA software like NemoClaw, right? And I will be using some models on-prem, of course, or within the platform itself that's self-hosted. Because it's an RTX 4000 SFF Ada, I'm not going to be able to use the latest NVIDIA Nemotron models. I'm not going to be able to use GPTs, right? Even 20B, I'm not going to be able to use. I'm going to have to use like Nemotron Nano, right? Or Quen models, something that's smaller or quantized to 4-bit, right? That gives me enough leeway on KV cache as well, right? Because remember, NemoClaw agents and OpenClaw agents, right? They have obviously memory, long-term memory, but you're obviously going to need KV cache as well. So what does this look like in a big, kind of like open here, right? So this is kind of the Nutanix Agentic AI solution, right? Is what I'm talking about. And in this case, right, we're showing you that partnered with NVIDIA, the Nutanix Agentic AI solution, but don't think of it as we're only supporting NVIDIA. That's not the case, right? The idea is that the Nutanix Agentic AI solution will support other solutions as well, AMD, Intel, et cetera. It's not, just for NVIDIA, right? It's a platform that you can layer in the partners that you want, right? You want to layer in AMD, so be it. You want to use AMD and you want your agentic workflow automation or agent building platform to be Crew AI, no problem. We're going to give you blueprint to deploy Crew AI, right? And you'll be able to use the tooling that you want. Meaning we're not building all this tooling and saying, oh, Nutanix we're trying to be the master of everything, right? We know we can't be, right? The idea is to give you a platform that gets you ready to consume and then gives you optimal flexibility for all of the tooling that you want to use. You want to use OpenClaw or NemoClaw, have at it. You want to build agents through LangChain, no problem. You want to build agents through Crew AI, go for it. What we're doing, right, is we're delivering that simply in the NKP application catalog as a deployment mechanism and a lifecycle mechanism for those third-party applications, right? Making it very, very simple, right? And that's the whole idea, right? And it brings in other things too as well, right? I talked about, I know I showed you just kind of the endpoints and the unified endpoint, right? The ability to, in this case, I have my unified endpoint, right? My gateway routing to the local endpoint first and failing over to GPT-4o Mini at OpenAI. You could change this, right? You can update this. You can, allow whatever API keys. You can rate limit. So one of the things that we do is you can actually limit. So what if you started in the cloud, right? So say I edit this endpoint and I say, okay, instead of the on-prem model, I want to use the OpenAI model first. And then I'll rate limit that because I want to control the cost, right? The cost of tokens. Because remember, all the frontier model providers, the SaaS providers are going to charge you token costs, right? So it's pay by the drip. Whereas the on-prem solution, you're not being charged at all other than the accelerated compute required to run the inference against, right? So it's not token based. And so you may say, okay, I'm going to give a budget for this set of API keys, right? And let me just go back here and show you what I'm talking about. I'm going to give a budget at a global limit, right? Meaning all API keys, or I'm going to do a per API key and say, okay, this demo FL-1 only gets 1,000 tokens per minute on OpenAI. And when it hits that, it's going to fall back to the localized Quen model. Okay, so now you're getting that cost governance and cost control around leveraging a hybrid AI solution. Yeah, I said it. People are probably like, oh boy, here we go. Another buzzword. Hybrid AI is the future, right? This idea of I'm going to do everything in the cloud, not going to happen. Okay. Some of you maybe, right? I'm not going to say it, completely, right? I don't like to talk in totality, right? But some of you will get away with using the cloud forever or a SaaS provider forever. But most will want to leverage, especially in the enterprise, most will want to be in a hybrid fashion. This is the same thing how it's playing out with public cloud, right? And what I see, meaning you're leveraging public cloud. The enterprise had this idea pre-COVID of I'm going 100% all in on cloud, and next thing you know, most everybody I'm talking to, they're running in a hybrid fashion. Why? For many reasons: cost, security, innovation, data governance, SLAs, all the same things, right? Now, the AI use case is, Jensen said something pretty remarkable. I'm gonna say remarkable, but he's just very smart, right? And he said, why would you outsource your intelligence? Meaning, why would you outsource all of your IP and trust it with, OpenAI or an Anthropic? Why would you do that? Now you can come back and say, well, Mike, they guarantee this. They don't guarantee. There's no guarantees, guys, period. Also, look at the fine print. I talked to customers that came back and says, we can't use Azure as an example, because if you look at the fine print, when we looked at it, it doesn't protect your data for a specific amount of time. It doesn't guarantee it. So you have to look at the T's and C's. You have to look at the fine line, right, of what's happening of these contracts that you have with these providers. Now, I'm not saying that you won't leverage them. There could certainly be use cases where that's not an issue, right? Where you're not, there's not PII, or you don't have to protect specific data. Maybe you're doing research, right? And the research is not, incurring any risk to you. And so you use OpenAI to do that. But maybe you have a solution on-prem where you feed your data into, right? And that data has to be governed and sovereign, and it has to stay on-prem. Or the solution that you created, not just the solution. And this is what's funny too. It's not just about the solution you create that's your IP, right? Your intellectual property around AI. It's the ideas. It's the actual thinking about what problems you're solving. Those are also sacred to you as well, especially with, against your competitors. And so you have to think along those lines that you will become hybrid at some point, especially in the enterprise. You will not all be using Anthropic and OpenAI only. You will have some on-prem solutions for the reasons I outlined. And so in that model, this is the perfect way of controlling cost to external, right? And routing to internal when it makes sense. The other things I want to talk about quickly are, and we'll talk about this, is the MCP server. I don't have anything set up to actually show you, but the connector. So what we do here is we give you complete governance, right, around MCP Connect. And this is one of the big problems with MCP, outside of the massive context that it leverages, right? There's, MCP comes with a lot of overhead. Okay. And if you look at Anthropic, I mean, they created MCP, and then all of a sudden they create skills, right? Right. And they now you think about harness, right? So the idea is that you may use MCP in certain use cases, and you may use skills in certain use cases, and in a mixture of those things. Or you may say, there's this, I see MCP is dead out there, articles on LinkedIn. I'm like, come on, MCP is not dead. Okay. Now, is there a lot of overhead to it? Certainly. Does it make sense to use it all the time? No. Right. And so it's not dead. Just like this whole idea of MCP versus skills, right? I mean, Anthropic created both, and Anthropic promotes both. There are use cases for either. Okay. Same thing for to me, it's the same argument of, not the same argument, but at the face, the same argument of VMs versus containers. VMs aren't going away, right? The container folks have thought that VMs were going away a long time ago. They're not going anywhere. Okay. And so there's going to be a mix of, you're going to be running in this hybrid fashion, VMs and containers, and you're going to be using more than likely, you're going to be using MCP and skills. Okay. Combined from that perspective. And so we've given you this model to actually control access to skills and what you can do with those skills, or excuse me, MCP servers. And so say an MCP server exposes 10 different things you can do. You can limit those things based on the, based on the connector, right? And based on the access, based on the API key. So you can say, okay, this API key only has access to get information from this system, right? But it can't change or write information or do anything that is high risk, right? So we give you the ability to control that. The other thing too is we've also included some fine tuning capability within the platform. So we know that training is not really where we play today. And generally speaking, we don't see a lot of customers doing their own training. They're either using RAG or they're doing fine tuning. Okay. And when I say customers, I mean like enterprise customers. Okay. Now I'm not saying that zero enterprise customers don't train. I'm just saying that we generally don't see that as a common use case. They're either doing fine tuning or they're doing RAG or a combination of both. Right. Fine tuning when the data is static, it doesn't change very often. And now I can apply that data to my model. If your data changes or you're adding data consistently, a RAG solution may be beneficial depending on the use case. And there's different types of RAG, right? There's graph RAG, which is becoming more popular in different scenarios. And so you have to start looking, start getting more in depth on those use cases as well. But the idea here is, now I can fine tune, right, within the platform itself. And you can, in this case, I'm using a file share as my data source, right? And in my file share, I have a file that it would be used to actually fine tune a model. And I can go in here and I can actually go in and fine tune. Okay, so actions. These are my data sources, right? My API keys, right? So now I have a platform to manage all of that. And I know this is about OpenClaw, but it doesn't matter. Agents or outside of agents, I still need model management. I still need MCP controls. I still need visibility and observability into the stack. It doesn't matter. Chatbot, agent, right? Doesn't matter. I still need those things. And I need to be able to test, right? I need to be able to validate quickly. If I'm doing chat, right, I want to actually see if this actually works. Okay, so in here you can see I have a unified endpoint called, right? This is the one I showed you. And you can see here I'm going to Quen locally and I'm going to Chat GPT if Quen stops working. So what happens if Quen stops working? You see it's active here, right? Let's go into the chat really quick and just validate that it works. What is NVIDIA? Okay, so that's being serviced locally by the Quen model, right, in my inference to this local endpoint. So if I click in here, right, I should be able to get, I'm sorry, I'm using unified endpoint. I click in the unified endpoint, I'll get all the metrics, the performance, right, the time to first token, the latency. And by the way, don't look at this and say, oh, Mike, your latency is so high, it sucks. Guys, I'm on DGX Spark, right? It's not made for performance, okay? Time to first token, right? All of that, right? I'm getting all the metrics that I want to get that I could get out of DGX Spark, but I'd have to build it, right? Like I can use Ollama. Ollama does some of that when you use Ollama and you use Open Web UI against Ollama as an example, right? You'll get some of this information. But what if I was using Open Web UI against NIM? You wouldn't get it. You'd have to build Prometheus and Grafana stack, right? A PLG stack to get this information, right? Or Prometheus, right? To get this information and pull data out and get this information. I don't want to do that. I want to have this readily available to me at all times in the portable OpenClaw platform. So I hope this kind of gives you an idea of the reason why I'm going down this path. I'm not using the DGX Spark. This will be very eye-opening from a testing perspective because I'm going to be doing things that aren't necessarily supported, of course. This is kind of what I do, just to kind of give an idea of what this could look like. And I think, looking at this as an art of the possible way of something that could come to fruition, right? Like, where would something like this be valuable? Well, what if I'm a warfighter out in the field and I need to get access to intelligence for specific reasons, right? Maybe I have a hardened platform. It's not the MSO2 Ultra, of course. It's a hardened platform. Maybe that size that's not burdening my soldier, right, to carry a bunch of servers in a mini rack on the back of a Humvee, right? Maybe it's in the palm of my hand, right? Or I can carry it like a suitcase, right? But it's a hardened suitcase. Think of those use cases. Or someone out in the field, right, that's doing some survey work, right? Geological survey work, things like that, right? This is what I'm talking about as use cases for a portable agentic platform, right? Okay, so I think I covered everything I wanted to cover today. The next section we'll get into actually building it. Again, I just got this. So hang on one second. Let me just go to see if there's any questions here. Okay, no questions so far. But that's kind of, the first phase of the OpenClaw portable platform. And then we'll get into the installation of all these things next Saturday. I'm going to try to do a 4-part series where we get to an end state. And you're going to see some of the challenges I'm going to have, right? Some of the challenges I'm going to have more than likely will probably be around the pass-through of the RTX 4000 SFF ADA on HV. We'll see if I can get around that, right? Because we do support PCI pass-through, but it's not officially supported that GPU, right? And then I got to see if that GPU can be supported on the NKP GPU node stack, right? Using virtualization. And I'm pretty sure I can get that working. That doesn't seem to be an issue. I think that could be pretty easy. We're going to enable GPU time slicing, right? Get all the foundational pieces up and running, the storage pieces, the data services piece using NUS, having that ready, and then getting into the OpenClaw side, deploying OpenClaw, right? More than likely it'll be a NemoClaw, deploying that, doing some testing, and then setting up some real use case. The first use case we're going to start with is getting the OpenClaw agents to actually manage this platform itself. And then we'll get into, okay, what can we do externally? How can we connect to super intelligence, right, with the frontier model providers using the gateway and all of those things, and start incorporating MCP and all of that. So this will be kind of a journey, right? I'm going to try to make it a 4-week journey, a 4-session journey. And by the end of April, right, the idea is to have this platform fully stood up, ready to go. And of course, sharing this back to you guys, and then you guys giving me feedback, hopefully. And then we can do a whole bunch of testing and have some fun with it. All right. So I hope you have a great rest of the weekend. If you celebrate Easter, happy Easter. I hope the weather is good by you. I'm on vacation this week. Thank God I actually need a break now. And I look forward to disconnecting. But next Saturday, right, we'll get into the installation of the software, the foundational software, and we'll walk through that piece. So again, have a great day, and I look forward to talking to you guys next week. All right, bye-bye.